Hello all, welcome to the playlist of Basic Mathematics. Today our topic is relations. In this video lecture we will came to know what are relations and how they are defined. Before coming to the definition of relation, we must know Cartesian product. Let us understand Cartesian product with the help of an example. Here we have two non-empty sets A and B containing the elements 1, 2, 3 and AB respectively. We want to find the Cartesian product of A and B, which is denoted as A cross B, and it is the collection of the ordered pairs A, B such that the first element of the ordered pairs come from the set A and the second element comes from the second set B, that is B. So if we understand it diagrammatically, let us construct the set A as this and set B as this. A is containing element 1, 2 and 3 and B is containing the elements A and B. Now the first element of A will map to the every element of B, and similarly the second element will map to the every element of B, and so will the third element. So A cross B will contain the elements 1, A, 1, B, 2, A, 2, B, 3, A and 3, B. So we can also find B cross A. Not only A cross B and B cross A, we can also find A cross A and B cross B. So let us understand how will we find B cross B. Now we have two sets and they both are B, containing the same elements A and B. Now the first element of the first set will map to the every element of the second set, and so will the other elements. So B cross B will contain the elements A, B, B, A and B, B. So here is the definition of Cartesian product. Now the first thing here to understand is Cartesian product is never commutative in nature. That is usually A cross B is usually not equals to B cross A. We can clearly see this in the example. Here we have A cross B and there is B cross A. A cross B is containing the element 1, A and B cross A is containing the element A, 1 and they both are not equal. So Cartesian product is not commutative in nature. And is that possible that A cross B is equals to B cross A? Yes, it is possible if and only if the first set is equal to the second set. Only then commutative law will hold under Cartesian product. Now the next thing we have to understand is, can A cross B be phi? Yes, it is possible if either of the set is phi. Means if A is phi, then A cross B will definitely be phi, or when B is phi and A is not, then definitely the cross product of A cross B is going to be phi. Now, if I construct a set 1, A, 2, A and 3, A, 3, B. So this is clearly the subset of A cross B. So here we came to know that A cross B, that is Cartesian product, can have subsets. So the possible number of subsets of A cross B are 2 to the power order of A cross B. That is 2 to the power 6 number of subsets are possible of A cross B. Now, what are relations? If I have two non-empty sets, let A and B are two non-empty sets, then definitely I can have A cross B, and if I have A cross B, then we can construct their subsets. So any subset of A cross B is known as a relation from set A to the set B. We can see here in this example, in this definition, where R is subset equals to A cross B. Now, if I have A comma B ordered pair belonging to the relation R, then we can write it as A capital R B, which is pronounced as A is related to B. And if ordered pair A comma B does not belong to the relation, then we can write it as this or this, and which is pronounced as A is not related to B in the relation R. So, we have a very important note here which says if A is a set containing n number of elements and B is a set containing n number of elements, then we can find A cross B. Then A cross B will have n into n elements. How I came to know about it? If A cross B, then order of A cross B is always equals to order of A into order of B. So order of A is what? M, and order of B is n. So here order of A cross B is always m into n. Then all the possible number of relations from A cross B are 2 to the power m into n. So let us understand this concept here. What is partition? What is the partition set of A? It is the collection of all the subsets of set A. So order of P of A, order of partition of A will be what? 2 to the power order of A, which is 2 to the power m. So partition of A cross B will have what? Collection of all the subsets of A cross B. So order of partition of A cross B will be what? Or 2 to the power order of A cross B, which is equals to 2 to the power m into n, and which is total number of relations from set A to B. Now, what is domain? Let us understand the concept of domain with the help of an example. Here I have a set A and set B. Relation from A to B is given to me. Now, domain is the collection of first element of the ordered pair which belongs to the relation. For now, I have ordered pair 1, 8 in this relation. So, the first element of this ordered pair is 1. So, it will get into the domain. The next ordered pair's first element is 3. So, 3 is going to be in the domain of R. And for the next ordered pair, I have 5. For the next ordered pair, we have 1 and which is already in the domain. So, it will not be repeated. So, domain of R will contain 1, 3 and 5 elements, and which is clearly subset of the set A. So, we can see the definition of domain here. Now, what is range set? Let us consider this same example, and I am interested to find the range set of the relation R. Then, it is the collection of second element of the ordered pair which belongs to my relation. Right? So, in this relation, I have ordered pair 1, 8. The second element of this ordered pair is 8. In the next ordered pair, I have the second element as 6. In the next, I have 2 and 4. So, it is clearly the subset of the set B. We must know when a relation is defined from set A to the set B, then this B set is known as codomain. So, range set is always subset equals to codomain. Now, here is the answer of this example and the definition of the range. Now, relation on a set. Let me consider I have only one set, which is not 5. So, I can find A cross A, and A cross A can have any subset. So, any subset of ordered pair A cross A is known as relation from A to itself. So, here is the definition. Now, inverse of relation. We will understand the concept of inverse of relations from the help of example. Here I have the set A and B, and the relation from A to B is defined to me, and I am interested to find the inverse of this relation. Inverse of the relation is the collection of ordered pairs B, A such that A, B should be present in the relation. It is the ordered pair B, A will only come if the ordered pair AB is in the relation. So, I have 1, A in the relation, so the ordered pair in the inverse of this relation will be A, 1. Simply means the first element will become the second and the second element will become first. And 1, C becomes C, 1. 2, D becomes D, 2. 2, C becomes C, 2. So, we can see the definition of inverse of relation here. And one note is, if A, B belongs to the relation R, implies B, A belongs to the inverse of its relation. And this is my if and only if result. That is both ways result. Next thing, what is the domain of relation R and the range of relation R? That is a subset of A and range is a subset of B, and domain of the relation R will always be equals to the range set of R inverse, and the range set of relation R will be equals to the domain set of inverse of its relation. So, here it is. In the next lecture, we will understand what are the types of relations, and we will practice some questions on these results. I hope you enjoyed the session. If you have any questions or any doubt, you can contact me through this email address.